So this is a question on refraction. It says a person 1 meter underwater sees the image of objects outside the water through a circle on the water surface. The question is to find the radius of the circle. Before we go into this, let's understand what is refraction and what is Snell's law. Let's say we have a water surface. This is a water surface, and we have a normal or perpendicular to the water surface. If we have a ray of light entering at the surface at an angle, let's say theta 1, let's call this theta 1, then this is going to be the normal trajectory of the light, right? Uninterrupted. But since we have air here and water here, when a ray of light enters from a rarer medium, a thinner medium, to a denser medium such as water, the ray will bend towards the normal. It will bend slightly towards the normal like that, and it will form an angle theta 2. It is bent towards the normal. So what does Snell's law state now? Snell's law states that, let's say the refractive index of air is, let's call it N1, and the refractive index of water is N2. Then Snell's law states that N1 sine theta 1 will be equal to N2 sine theta 2. This is what Snell's law states. Now with this information, let's get into the question. Let's say there is a person here. The height is 1 meter. The depth is 1 meter. We have a person standing here underwater, and then he's looking at the image through the surface of the water. And let's say a ray of light from one of the objects is going to hit his eye, and it can come from here, and it is bending towards the normal, and it's going to form an image through that. In his eye, he's going to see the image. But if you look at it, let's say this is the normal. The maximum angle of incidence can come from a ray which is almost horizontal or 90 degrees. Let's call it 90 degrees. This is the maximum angle of incidence possible to the normal, which can form an image for him. So if that is going to be the angle of incidence, similarly on the other side also, there's going to be a maximum 90-degree angle which is going to get into the image for him. So if this angle, let me shift the normal here, this angle is 90 degree, which means theta 1 according to our Snell's law is 90 degree. Let's substitute this in Snell's law and see what is going to be the theta 2, this angle. The angle over here is going to be theta 2. Similarly, on the other side of the triangle also you're getting theta 2. So refractive index of air is 1. So let's substitute 1 for N1. Sine theta 1 is sine 90, which is 1. N2 is refractive index of water, which is 1.33 sine theta 2. From this we get sine of theta 2 going to be 1 upon 1.33. When we simplify this and take a sine inverse of 1 by 1.33, we get approximately 48.75 degrees, which means theta 2 is going to be 48.75 degrees. Now if we simplify this diagram and draw it like that for the person standing underwater, this is going to be 48.75. Similarly, on the other side, there's going to be a 48.75, which means if we add both, approximately 97 or 98 degrees is going to be the total angle. And this will happen across the surface of water. So if you look at it from a top, it will be a circle here. So every point on the water along the circle is going to form the image for him. So it's similar to the person holding a cone and looking through the cone on the surface of water. So now if this is going to be a 97-degree angle for the cone. So let's simplify this further, and then so the radius of the cone is going to be the radius of the circle of the base of the cone. This is going to be the radius, and the height is given as 1 meter, and the angle is 48.75. Let's form a triangle with this. This is how the triangle will look like. 48.75 degrees. This is going to be 1 meter, and this is the radius. Now the question asked is, what is this radius? Now this becomes simpler because we know that tan 48.75 from this triangle is going to be opposite side r upon 1 adjacent side, which means the radius is nothing but tan 48.75, which if we calculate would come to approximately 1.14 meter. So this is going to be the radius of the circle through which this person is going to see the image through the water surface.